Today, I'm going to talk about packed textures. Many people think of one texture as serving a single purpose, but that's not always the case. At first glance, they can look like a mix of random colors, but there's actually much more happening behind the scenes. A texture can contain multiple channels: red, green, blue, and sometimes alpha, which is often used for transparency. Each channel stores its own grayscale data, representing intensity values rather than visible color. When combined, these channels form the final image. In game engines and 3D software, however, these channels don't have to be used together. They can be accessed independently, allowing us to store different types of data in each one. For example, in my case, I need 4 grayscale maps to achieve the effect I'm looking for: lighting, ambient occlusion, highlights, and inlines, the drawn lines inside my model. Keeping these maps as separate textures increases the amount of data to manage and isn't always the most performance-efficient approach. That's where packed textures come in. With packed textures, we can store multiple grayscale masks inside a single image by assigning each one to a different channel. In this video, I'll show you how to create packed textures using Substance Painter, Photopea, and Krita, and how to set them up correctly in Unreal Engine and Blender. The workflow in Photopea is identical to Photoshop, so Photoshop users can follow along as well. I've added chapters for each section, so feel free to skip to the software you're most interested in. Let's start with Substance Painter. In Substance Painter, when working with predefined templates, your final textures may already include packed maps such as metalness and roughness. The challenge appears when you need a custom setup, which is common in stylized rendering. There are a few ways to handle this workflow. Here, we'll look at a basic method, followed by a more standard recommended approach. The basic method uses one fill layer per color channel: red, green, blue, and alpha. Each layer should use a pure channel color: full red, full green, or full blue. Any other value would be incorrect, unless you intentionally combine channels, for example, painting yellow to affect both red and green at the same time. The background should remain black, since we do not want any default color value. With this setup, if the blend mode is left to normal, each painted value will overwrite the others. This means you lose the data stored in the other channels, which is correct if that is your intention. However, if each channel needs to preserve its details even when other colors are painted over, not every blend mode will work. The blending must preserve proper channel information. For example, blending pure red and pure green should result in yellow. For this reason, the blend mode should be set to linear dodge add. This simulates painting the channels independently while still allowing them to combine correctly. In practice, this means that painting over existing data will blend values instead of replacing them. For the alpha channel, I use the opacity channel, which can be enabled in texture set settings using the plus button next to channels. While you are in this section, it's also a good opportunity to remove any channels you don't need. As a side note, it is not necessary to display transparency in the viewport for the texture to export correctly. However, if you want to preview it, go to shader settings and switch to a material that supports alpha blending. On the alpha layer, disable all channels except opacity. This prevents unwanted color data from being painted into that channel. In my case, I set the alpha layer to black for transparency and the background layer to white, so the default state is opaque. From here, you can add paint layers and use blending modes or filters directly within those fill layers. If you prefer, you can apply the linear dodge add blending mode to a group instead of directly on a single layer. You can then place multiple layers inside that group. The layer colors still need to match the correct channels: red, green, or blue. For alpha, the setup remains the same. Now let's export this and check the result. Go to Export Settings, then open Output Templates. Create a new preset using the plus button next to presets and give it a name. Under Output Maps, choose RGB plus alpha, so the texture is exported as a single packed image. Set the texture name to match your texture set name, usually the material name, and add a packed suffix. Since we painted in the base color channel, drag base color into the RGB slot and set the source to RGB. For alpha, drag opacity into the A slot and set the source to grayscale. Set the output format to TGA 8-bit. Now go back to the Settings tab, select your new output template, set an export path, and export the texture. If we open the texture and inspect the channels, we can see that the data has been preserved correctly. We can also verify this using the eyedropper tool. Since the maximum value for a channel is 255, we can confirm that the values are accurate. The main limitation of this method is that it relies on the base color channel, which can be inconvenient if you also need to paint standard color data. Linear dodge add is the closest approximation to independent channel painting in Painter, since it preserves and combines channel data without overwriting it. However, it is still an additive operation, so it is not the same as true channel writing. There is also the fact that base color is treated as sRGB rather than linear, which is not ideal for packed data. Most engines can usually convert it properly, but it is still not guaranteed to be fully accurate. That is why the recommended approach is to use custom channels, which are linear by default and independent from the built-in channels. To add a custom channel, go to Texture Set Settings, click the plus button in the Channels list, then scroll down to User Channels. Once added, these channels can be renamed to match your workflow, for example, lighting, AO, reflection, or inlines. Once created, these channels will appear in your fill layers and brush settings, allowing you to edit them individually. This setup needs to be repeated for each material that uses this workflow. To display them in the viewport while painting, use the Channel Display dropdown in the top right corner. Your custom channels will appear there, and all materials using them will update accordingly. In my case, the model is split into multiple materials, all using the same channel setup, so switching the viewport channel updates all of them at once. At this point, you can stack layers and use effects or blending modes as usual, as long as the correct channel is enabled in each layer or brush. One important thing to keep in mind is that blending modes are channel specific. If a blend mode does not seem to work, make sure you are editing the correct channel using the layer channel selector. Each channel blends independently, so this is something to always keep in mind. To export your textures, you need to create a custom output template, similar to the previous method. This setup only needs to be done once, but channel assignments should always be verified per project. Go to Export Settings, then Output Templates. Create a new preset and add an output map with 4 channels. Use the TGA format at 8-bit. Name the texture as needed. Here, I use the material name with a packed suffix. Next, assign your custom channels to the R, G, B, and A slots as a grayscale. Your custom names will not appear here directly, so it helps to remember their order. You can hover over them in Texture Set Settings to see their original names. Once everything is set, select your template and export. If configured correctly, your textures will already be packed. By default, templates apply globally, but you can assign different ones per material if needed. After export, verify the texture to ensure all channels are correct. One limitation of this workflow is that Substance Painter only exports data within UV mapped areas. If you paint details outside UV space, they will not be preserved cleanly in the final texture. If I want a specific pattern on alpha channel, which I don't want to get affected by the UVs, I would discard the alpha from my template, then export. I would bring that texture in my texture packer tool, which help manage packed textures. Then I would input my custom mask to the alpha channel. This allows you to continue working in Painter, and whenever needed, re-export the channels, refresh them in your external tool, and generate the final packed texture. I'll be using Photopea, which is very similar to Photoshop, but free to use. It does include ads on the right side, which I'll hide with a custom image. The workflow is essentially identical to Photoshop, so you can follow along in either software. Like in Substance Painter, you can paint on standard layers using the normal blending mode if channel blending is not required. The issue appears when you need to blend channels. Some blend modes can appear to behave correctly for packed textures, but they are still performing color blending rather than true channel editing, which is the same limitation we saw in Painter. Because of that, the results are not always reliable, especially when precise values are required. The first and basic approach for creating a packed texture would be to edit the texture channels directly. Next to the Layers tab, open the Channels tab. You'll see red, green, blue, and RGB, which is the composite view of all three channels. If you don't see them, make sure your document is set to RGB mode and 8 bits per channel. For this workflow, we'll treat each channel as a grayscale mask. Start by filling the channels with black, then paint on them using a white brush. These grayscale values control the intensity of each channel. When you switch back to the RGB view, you'll see the combined result. Now, if we overlap strokes, the colors will blend correctly, without removing each other's values in the other channels. I mentioned earlier that there is also an alpha channel. This is optional and is often used for transparency, but it can also be useful as an additional mask. To create one, click the New Channel button at the bottom of the Channels panel. One downside of working directly with channels is that you lose the convenience of layer-based painting. Working only in channels is a bit restrictive, so the second method lets you use layers instead. As mentioned earlier, there are no blend modes that will fully solve this for us. However, if you double-click a layer or a group, you will see checkboxes for R, G, and B. These determine which color channels the selected layer or group is allowed to affect, and they can recreate the same effect as painting directly into the channel. An efficient workflow is to create groups named after each channel and assign them the corresponding channel color instead of applying it to individual layers. You can then work normally inside those groups using different blending modes and tools. There is no need to paint full color information, since only the grayscale values of each channel will be preserved. There are no similar options for the alpha channel, as far as I know. So, for the alpha channel, you can keep the edits in a separate group. When the edits are finished, create a flattened version of the alpha group, then copy the result into the alpha channel. Once you're happy with your packed texture, it's time to export it. Be sure to turn off your alpha group first. A TGA file is often a good choice overall for this type of texture, as it is widely supported, no compression loss, and can include an alpha channel when needed. If a save dialog appears in Photoshop, use 24 bits when there is no alpha. If you are using an alpha channel, to make sure the file is saved as 32 bits so that the channel is not lost. In Krita, the setup is a bit less obvious than in Photoshop. As mentioned in the other options, simply using layers with colors and the usual blend modes will not give an accurate result if we want to fully control the color channels, especially when those colors overlap. There are a few steps to get started. First, create a new document in RGB with alpha, 8 bits per channel, and fill it with black, which represents a value of 0. In Krita, you can view the channels, but you cannot paint on them directly like in Photopea or Photoshop. A few steps are required before we can paint into them. With your layer selected, go to Image, then Separate Image. A window will appear. Set the source to current layer, and make sure Create Separate Separation from Alpha Channel is enabled. This will split the image into multiple layers representing the RGBA channels. Since the original image is black, all the layers except the alpha will appear black. If you're editing an existing packed texture, you should see each channel separated correctly. You can group these layers and hide or delete the original background layer, as it will not be needed anymore. At this point, painting directly on these new layers will not give the expected result yet, because we need to adjust their blending modes. For each layer corresponding to red, green, and blue, change the blend mode. Go to the MISC section of the blending modes and assign red layer to copy red, green layer to copy green, blue layer to copy blue. These blending modes allow each layer to write its values into the corresponding color channel without affecting the others. Now, when you paint on each layer using grayscale values, the result will be written into the correct channel. You can also use multiple layers if needed, as long as they keep the correct blending mode. If you need more complex details and want to use multiple layers and blend modes, you can group the layers and apply the copy to color channel mode to the group instead of each layer individually. After that, anything inside the group will affect only the corresponding channel. The alpha channel works differently. Instead of using color, it controls transparency. Painting adds opacity, while erasing removes it. However, if you import an existing mask, you do not want to do that, since it may already contain important painted details that should not be altered. In that case, use a filter that turns darker values into transparency. Simply add the color to alpha filter and set it to black. Now pixels will fade as they get darker, and your painting should appear correctly. When exporting, simply save the image as a TGA file, and the channels will be packed correctly. In Unreal, we cannot use that type of texture as is. Technically we could, but the result would not be accurate, because by default it would be treated as diffuse color. Since we want to use the grayscale values in the texture, which is the point of the packed texture, we need to turn off sRGB. After that, the best compression setting depends on the situation. A good rule of thumb is to start with the cheapest option, such as masks, no sRGB. If you see too many artifacts that affect the look of your model, increase the compression to BC7. If that is still not enough, you can try vector displacement map. Be careful though, as you increase the compression quality, it becomes less compressed, defined by higher quality larger in memory. In many cases, you can reduce the resolution a little to compensate for that extra cost. Why artifacts can appear? Even if the grayscales are in different channels, it can happen that they affect each other. Increasing the compression helps prevent that issue. If you create a material using your packed texture and it already has the correct settings applied, you should see the sampler type set to mask or linear color, which is correct. You can now use each channel however you need. To use a packed texture in Blender, simply set the color space of your texture to non-color. To use each channel independently, add a separate color node after it. Each channel will then be available individually. The alpha can be accessed directly from the texture. In the end, the best workflow depends on the kind of texture you're creating. If all your masks share the same UV layout, Substance Painter is very efficient and painting directly on the model is much faster. However, if one channel needs a pattern that must remain intact, combining the final texture outside of Painter is often the safest solution. If you need more direct control over individual channels or non-UV based data, tools like Photopea, Photoshop, or Krita may be a better fit. I hope this helps, and thank you for watching.